Hi, welcome to this lesson on volume and surface areas of prisms. If you could pause the video right now and take down these notes. There are quite a few of them, so it might take a bit of time, but it is important that you get them down so that you can then watch the rest of the video and then only have to add very few things and actually pay attention to the maths that's going to be shown. Alright, so assuming you've done that, we're going to carry on with the lesson. Right, so we're having a look at the volume and the surface area of prisms. Now, often these sorts of things are kind of misunderstood, so I'm going to go through what each of these things mean. So firstly, you're looking at a prism. Now, a prism is a three-dimensional object, and the definition of a prism, which I've got up here, is a 3D shape whose sides are all at 90 degrees to each other. Now, I said sides there, I should have actually written faces. And the reason for that is, if I've got a 2D shape, such as a square, something like that, these are the sides of a square. As soon as I make this shape three-dimensional, something like that, these are no longer sides, they become faces. So I've actually got an object here, and so this, for example, hold it quite close, this is a prism because each of the faces are at 90 degrees to each other. You can see this side here is at 90 degrees to this, this face here is at 90 degrees to this face here. Likewise, this one with this one. Each of them have a 90-degree angle between them, all right? And the difference is between a prism and another shape, for example, a pyramid, both of them have the same base, they're both square-based, but as you can see, my prism is actually at 90 degrees to each other, whereas this one kind of comes to a point. All right? Now, the volume of this is very different, or it's different to calculate as opposed to a prism. Because a prism, there's a universal method for calculating the volume of a prism. The surface area, which I'll deal with in a moment, is actually the same. The way you calculate it is the same. But I'm not going to be dealing with pyramids, I'm just going to be dealing with prisms for this lesson. Okay, so that's what a prism is. Next two things is volume and surface area. The volume is simply how much space this actually takes up. So a really nice and easy way of demonstrating this, which I'm not going to do now, I want you to imagine if you took an object and you dropped it in some water, let's say your mobile phone, because you've definitely done that before. Let's say you drop your mobile phone in a bucket of water and it displaces some water. In other words, if the bucket were really full and you dropped it in, the bucket would overflow. That's because your phone has a volume, it takes up space, right? And that is the volume of an object, right? It is the amount of space that it takes up. The surface area is simply the area of each of the surfaces. So this one here, this one here, this one here, there, and there. Right? Now, the good news about that is it's quite easy to work that out because hopefully you've already done nets. If you haven't, have a look up on YouTube or Khan Academy or perhaps one of my other videos. Look up drawing of nets. Right? That will help you out with this. But basically, if I were to turn this, a net is simply, I take that shape and I unfold it like that. I turn a 3D shape into a 2D shape. I kind of unfold it. It's very similar. It's often used with wrapping of presents. Those style of questions. They use nets. The surfaces, the surface area of all of the faces of the shape, and we just kind of unfold it like that. So I'm going to deal with this now. Let's have a look at the volume. So if I have a look at the volume of a prism, it is simply the area of the base times its 3D-ness. And I put that in inverted commas because 3D-ness is not a mathematical word at all. It's normally described as area of base times height. I'll show you why. If I take this shape, we'll deal with the square-based prism. I'm going to deal with other prisms as well. But if we deal with the square-based prism, what I've done is I've taken my square, which is there, and I'm just going to turn it on its point, I guess, because it's easier to see the 3D properties of this shape if I have it like that. All I've done with this square is I have extended it upwards. Right, this is actually a hidden line. It goes behind there. All I've done here is I've simply extended my shape upwards like that. Not the best drawing, but all I've done, if you can imagine, here is my shape. Okay, you can't see it. It's just a flat square, and all I've done is I've just kind of given it a bit of volume like that. I've made it from a 2D shape into a 3D shape. So what you're actually doing is you're going, well, what is this area times by how much 3D-ness I've given this shape. Alright? So that's why I call it 3D-ness. And the reason I call it 3D-ness is because sometimes it's like that. It's on its side. Right? Or I've got a different prism. This is a hexagonal-based prism, because the base is a hexagon. And what if it's like this? I mean, it's fine if it's like this. I've got my hexagon. I can be given the area of the hexagon, or some way that I've been required to calculate it. And yeah, I can see the 3D-ness. Yeah, that's brilliant, cool, that's the height. But now what happens if it's on its side? Okay, it still has height. It's whatever gives the base its 3D property. So I've kind of coined that word 3D-ness. Right? Please don't put that in your exam. It's not a maths word. We normally say area of base times height. So let's do some calculations on this. So let's say it's a square-based prism, so this is 4 centimeters, and that's 4 centimeters. Let's say I got a height of 10 centimeters. So what I'm going to do is I'm going to try and find the area of my base. And if you're unsure about what your base is, I want you to think, what's the main shape on here? If this were a loaf of bread, and you cut into it, and you cut a slice out of it, what shape would that slice be? That is your base, alright? No one is going to have a loaf of bread like this and cut it like that. It just doesn't make sense. You could, there's nothing stopping you, but we don't conventionally do that. So that is your base, that's going to be your base shape. So you find the area of that base shape. In the case of a square-based prism, much easier. Alright, so I find the area of that, so 4 times 4, brilliant, that's going to give me 16. And now, remember, it's area of base times whatever gives it 3D, its 3D appearance. So in this case, it is the height. So I'm going to times that by 10, and that's going to give me 160 centimeters. Now, because we are dealing in centimeters, and I've now turned it into volume, whereas if we used area, it would be centimeters squared. Volume, I use centimeters cubed, because it's how many little cubes, each being 1 centimeter by 1 centimeter, can I fit into my 3D shape? How many of them will fit in? Right, and I can fill this whole thing up. So in this case, there'll be 160 of these little 1 centimeter by 1 centimeter cubes. That's basically what centimeters cubed is referring to. If I do a slightly different shape, let's say I decided to have a triangular-based prism, totally fine. Here we go. Bear with me, it's going to look a little bit strange, but you'll see what it is that I'm doing. Alright, there we go. Alright, so there's my triangular-based prism, and I put this little sign in there to show that this is my base. So let's say my base is 5, and my height is going to be 10 of my triangle, my base, and then it's been given 20 centimeters there, or 1 centimeters. I'm going to now try and find the area of my base, because area of base times the 3D-ness. So here's my area of the base. There you go. And by the way, if this was drawn on its side, let's say it looked something like that. Okay, that's 5. Alright, and then it was just extended out like that. Like that. That is still going to be the area of base. It's still going to be the area of the base, alright? Because that's the slice of bread, that's the shape of the slices of bread that I would be getting out, okay? And then I would again times it by whatever gave it 3D shape, whatever gave the 3D shape to it. So area of my base, I know the area of a triangle is half base times height. If you don't know areas of shapes, have a look up properties of shape. Specifically properties of triangles, or look up area of a triangle, area of a rectangle, those sorts of things, so you can actually find that out. Right, so in this case, just differentiate between these two questions. In this case, I'm going to have area of base, length of base times height, halved, or half base times height. So either way, I'm going to have half times my base, which is 5, times my height. It doesn't actually matter which is which in this case. That's going to give me 50. Half of 50 is going to be 25. And I mustn't forget, I need to multiply that by 20. So that's going to be times by 20. Multiply that by 20. Easy way of multiplying by 20, double it, and then times it by 10. So I get 50, 500. Okay? And again, my units, centimeters, because I'm dealing with volume, it's centimeters cubed. Okay? Now, I'm just going to erase this because I'm going to use these same shapes, and we're now going to find the surface area. Now, as I said earlier, if you haven't looked at nets, please have a look at nets, because it is much easier to think of surface area in terms of a net of a shape. So for example, if I had, where am I going to do it? I have my pentagonal based prism, because it's based on a pentagon. I want the net of this shape, okay? I want the net of a pentagonal based prism. And the net of a pentagonal based prism, there we go, there's my pentagonal based prism. If I unfold it, it's going to look a little bit like that. It's important that you are able to see a shape unfolded. That's a skill that you need to develop. If you haven't got that yet, do a bit more exercise, a few more exercises on it. Khan Academy is great for this sort of stuff. All right, next, so if I were to expand these out, right now, I'm going to try and get rid of some of this stuff here so we can make it a bit more clear. Let's get rid of my base there. And now what I'm trying to do is I'm trying to work out how many faces I've got. Well, I've got a base here, and I've got the top there. And then I've got side number 1, side number 2, I'll have side number 3 around the back, and side number 4 around that side. I always try and number them so that when I draw out my net, I know that I've got everything. So if I draw this out here, that's going to be my top, and I've got side number 1 over here, side number 1, or face number 1, sorry. Then I have my bottom over here, and then if I just kind of extend it, I'll have face number 2, face number 3, and I'll put on this side, face number 4. And it doesn't really matter as long as I've got 6 of them. Alright, so now I then take my measurements. This is going to be 4 by 4, which means that the top is going to be 16 centimeters. And because I'm dealing in area, the surface area, it's going to be centimeters squared. Please make sure that you do that. The base is also 4 by 4, so that's going to be 4 centimeters by 4 centimeters, which is 16 centimeters squared. For this one, let's have a look at base number, or let's look at number 1. Number 1 here is going to have a base of 4 centimeters, and I knew that actually because that was 4, and the height is going to be 10, so that's actually going to be 40. And in the case of this, all my bases and all my sides are the same, because that's going to be 4, that's going to be 4, and that's going to be 4. If you have a rectangular based prism, that's not going to be the case. Like, these sides will be different. That might be 4, that might be 4, but then that might be, I don't know, 5, and that could be 5, all right? So you need to bear in mind, double check the measurements on that before you start calculating. All right, so I'm just going to put in here 40, because 4 times 10, 4 times 10, 4 times 10. And so that's going to give me 40 plus 40 plus 40 plus 40. I'm just going to add up the sum of all the areas. So 40 plus 40 plus 40, 4 plus 4 plus 4 plus 4 plus 4 plus 4 plus 4, 160, or 16 with an extra 0, 160, so 160 plus 32, which is 16 plus 16, that's where I got that, and we add that up, 2, 9, and 1, so my total surface area, the area of all the surfaces of that shape, is 192 centimeters squared. Please don't forget your units. You're dealing with area. It must be units squared. It could be meters squared, or centimeters squared, or millimeters squared, or even square inches or square feet if you're dealing with imperial. But make sure you are dealing with the correct units. The volume is units cubed, surface area is units squared. Very quickly, I will do this last one here. So in this case, I've actually got 2 triangles. So we'll say that this is going to be the base down here. It's going to be the base. That'll be the top. Then I've got side number 1, or face number 1, face number 2, and then round the corner here is going to be face number 3. Right, so let's do that. Let's just put the triangle out, so that's going to be the top, and then I've got face number 1. Okay, so that's the top, that's face number 1, and I'll have, whoopsie, and I will have the bottom bit there. Okay, so that's going to be face number, so that's going to be the bottom here. And then I've got 5, 10, and let's say they haven't actually given us this. At this stage, they might ask you to calculate it using Pythagoras' theorem. You can do that. I'm not going to do that. I'm just going to kind of roughly guess, and that will be, I reckon, in the region of 12. It'll be less than 12, so let's say 11. We'll just say that's 11. 11 centimeters. I'm sure it'll be different, but let's just say it is 11. Right, so I just need to make sure, and the reason I needed that was because if I'm thinking about face number 3, which actually sits off here, face number 3, this side here and this side here match up right here. Okay, so I actually need to know that. because I know that this is 20, but I won't know what that is. And they can ask you to calculate it, or the questions can ask you to calculate it, but in this case we're not going to do that. We're just going to assume we're given it. So that's actually 11. Oh, I haven't drawn face number 2. My apologies. There's face number 2 over here, and obviously this side here and this side here, they match up, and they match up over there. Alright, so that's going to be 10, and then the base here is 5, that's 5, and then the height, the thing that gives its 3Dness, is 20 all the way across. Now, in this case, my base and the top are both exactly the same. I know that that is 10, so I can find my area of this face, and if I do that, put it in red. Half base times height, so base times height is 50, half that is 25, and again, centimeters squared, which I'll put in at the end. Sorry, that should have been there, centimeters squared. That's 11 times 20, so 11 times 10 is 200, and then add on another 20, so 220. And then here I'm going to do 10 times 20, which is 200, and then here 5 times 20, which is going to be 100. Alright, and obviously this is the same, the base is the same as the top, so that is going to be 25. Alright, so quickly we can add this up. 25 and 25 is 50, 100 and 200 is 300, so that's 350, so 350 plus 220, add up 0, 7, and 5. 570 centimeters cubed. Oh, sorry, squared, because I'm dealing with the surface area. Okay, please make sure you are aware of your units. Alright, so that is the volume and surface area of prisms. I hope that was informative. Please feel free to rewind, pause things, copy down what I've done on the board, see if you can work it out yourself, perhaps even set yourself your own questions, draw a shape, see if you can find a surface area and volume, take it to your teacher and see if it's correct. Alright, if there's any other questions you have, please have a look on YouTube, Google them, check out Khan Academy, loads of resources out there. Alright, so hope you enjoyed that lesson. That's it for me. Cheers.